Hello. So this video will cover our review of functions, and I'm going to go through the lab. Our lab this week will be different than the in-person section. So you'll notice if you type in um, hand in for uh, if you just type in hand in, you'll see that there's both a lab 7 and a lab 7 underscore 301. Um, our lab will be lab 7 underscore 301. That will be the online section. Um, let's just take a quick look at functions real quick before we get started. So functions have kind of four different parts to them. And we see most of them right here. The first part is the name. That goes along where you say def, my function one. My function one is the name. Def is explaining that is what you're defining the function as. The second part is the parameters. Uh, those are what go inside our parentheses. The third part is the body. The body is all of the different statements and expressions that go after the function. They're indented after for. So if we had multiple print statements here, all of those would be part of the body. The last part of the function is the return value. Those I don't think we have great examples for. So I'm gonna just go ahead and start. Let me go ahead and I'll do this inside the right place. Yeah, I'm in. So this is where I am. So if you want to see these files, they're underscore ACOX, public, CS151, and you'll see everything I have. So I'm going to go ahead and check out our lab 7. Check out lab 7 underscore 301. So got all those in there. So let's go ahead and go into that directory. Let's see what we have. So there's two files, analyzer and print data. Print data is something you don't really have to do. Don't change it. This is just something I'm using to normalize the output that you have. The real thing that we'll be doing is inside Analyzer. You see there's this big block that has instructions of what we'll be doing. We're going to basically, we will take input, standard input. The easiest way to do it is just to redirect from a file, and I'll show you how to do that. We will do some rudimentary analysis on it. We'll look for the largest word in the file. We will look for the line that has the largest word in the file. And then you guys will finish up by doing, you will look for the entire line containing the most U's, the entire line containing the most spaces. So looking through here, if there's a tie, return the first one you found. So if you have, whatever your input is, if you process 10 lines of input, you know, the first line has 10 U's and the fifth line has the most U's, you want the first line. You can see here where I said that print data is used just to normalize the output. That's what is going on here. I'm just importing that function so that I have it to be used. I'm using it down here. So this is the only output that I want your file to have. So they already have the variables being passed to them that I want to that the value should have, and all the variables that you need are already defined here. So when you find the line with the most U's and the number of U's and the line with the most spaces and the count of the most spaces, you want to use these variables. So you need to populate those with the correct values. Those are what I'm going to use to test it. This file will be available to you, so you are more than welcome to copy to grab the file from this public directory that I've outlined here. Tilde ACOX public CS151 lab 7 underscore 301. You should be able to grab all those files. Yes, everyone has read access, so you should be able to get to those So you can go ahead and use that to get you started. You can also follow along, and so as long as you sort of have the output and you put your data into the largest word and the largest word line, following along should be able to do that as well. Okay. All that said, I got kind of sidetracked myself. What are functions? So a function, we've already said the different four parts. We define it, we give it a name. Let's do something simple. How about subtract? We'll go ahead and get a function called subtract, and we want, let's just give two numbers, x and y. This is important. So when you have a function, the body of it needs to be indented. In this class, we typically use 4 space indents. So go ahead and give it 4 spaces. And then, so this will just be, to do this, we want to subtract y from x, and we want to return the value. Now, return is different from printing. So I could say, difference is equal to x minus y. I could print diff. That does not return. Not a return value. All this does is just prints it to standard output. That makes it so that you can see it. It does not return it. It is not the fourth part. To do that, you have to actually type return. In this case, we want to return the difference. So we can print it and we can return it. We don't need to print it, so let's go ahead and comment that out. And so this is a valid Python file, but it doesn't do anything because all I have done is I have defined the function. I defined it, I did some stuff in the body, and I returned it. So I've named it subtract. I gave it some parameters that we can use. But if I run this file, it's valid. It just doesn't do anything. If I want it to do something, I can go ahead and I can call it. So subtract, I just give it 2 values. So let's say, if I give it 10 and 7, and this time it doesn't. It does it in line here. So now if I call it again, oh, it returned it, but it didn't print it. So let's say my difference is equal to, and then I can print my difference. There we go, 3. 10 minus 7 is 3. So I think this was probably the most confused thing, or one of the most confused things on the test. So we haven't done a lot for return values, and maybe even in this I was looking through, we didn't really do any returns. Every Python function returns a value, even if now you don't have to explicitly return something, but even when you don't, something is getting returned. So let's look at that. Let's open up the Python 3 REPL, read about print loop, and let's define a function that returns, and maybe we can even have it take nothing. So like I said, when you print, you're not actually doing anything. So you can print hello. And then I'm not going to return anything. So that's my function. If I call it, it prints hello. This is what we're used to. But I can also assign something to it. So let's call my variable should be nothing equals returns nothing. And so it still prints hello. So the printing is completely separate from what it returns. But what is should be nothing. So I type it, and usually if I hit 7, it gives me the value of whatever it was. So in Python, when you have a nothing, it's actually called a none, capital N. So you can test this, should be nothing, none. There you go. So every Python function returns something, even if it's nothing. So yeah, 4 parts. You have the definition and the name. You have any parameters that you might have over here. So any parameters that you might want to pass. And then you have the body and the return value as part of the body. Okay, so let's go ahead and work through part of the lab. If I can open the right file. Open up Analyzer. And so I'm going to tackle looking at the largest word in the file and the entire line containing the largest word in the file. So this is a valid file as it is. So if I call Python 3 on my analyzer, it prints out some stuff. It prints out this largest word, most usable in line with some values. These are just the default values that I've given to the variables that we're printing out. These are what we want to change when we go over something. So, drop that away. Open up Analyzer back again. And then I want to drop this right here. So, since I want to find the biggest word, let's stick with that. So I'm looking for the largest word. And what I want to do is I want to have my biggest word. So let's just say what I want to do is I want to go over each line in the input and see if this line has the largest word so far. So we're fairly comfortable with this. So there's a couple ways to do this. I'm just going to do it with a forever loop. So while true, and we know while will keep looping as long as whatever expression is here is true. So I'm just going to pass it true. So I'm going to have basically an infinite loop. It will continue to loop until I break. If the program fails, something bad has to happen. All right, break, not necessarily bad, but go ahead and indent my 4 spaces after while true. And reading from the standard input is exactly what we've done up till now. So that is just the input command. If I don't give supply an argument to the input command, it doesn't prompt. It just looks for the input. So that's what we're going to do. So let's go ahead and call our line to the input. So I have my line here. And now I want to go over it. Now I have this line in my head and on here. And we need to find the biggest word. So I'm briefly going to define the biggest word as being the largest sequence of non-space characters. So any punctuation, any letters or numbers, I will consider to be part of a word. So, you know, if I had a string, this was my line, the fish can swim well, and 7 times. Every single one of these would be a word, including 7. Get this nonsense out of here. And so how do we do that, right? So actually, let's bring the nonsense back. So if I'm looking for the biggest word, I need to sort of keep a counter to my current biggest word, and I need to keep a reference to whatever it is. So let me go ahead, and I know that I'm going to have a locally big word. And this one will be specific to the line. And then I will have a working word, which will be the word that, you know, if I've already processed the, and the is my current big word, and I start on fish, fish will be my working word until I get to the next space. We're going to set these both to empty strings. And now what do we need to do? So let's go ahead and start iterating over them. We haven't really got to strings and lists yet, but just like when you can, for a number in a range of 10, and you can iterate over the values in this range, you can do something similar with strings. Let's pop out of here. So if I have a string, my S has the value string in it. I can say for each character in my string, if I were to print each one, it's going to go character by character, and it's going to print each one on a line as print instructs it to do. So we should expect all these to be one per line. So you can see we can, just by doing this, Python kind of gives us an easy out. So this is something we haven't really got to, but it's fairly simple. So go ahead and do it. Let's just do something a little more interesting. And we'll be into it over the next couple weeks anyway. So I have my line. Line is my string. So let's say for each character in my line, 4 spaces. What do I want to do with each character? So I need to add one to my, so let's look at this line here. So if I'm right here, right, I just want to add it to my working word. If I'm here, if I hit a space, space is my only character that is not in a word. So if I'm here, basically I want to close up shop on my working word, and I want to see if it's bigger than the biggest word that I've seen so far. So let's go ahead and test for that space, because that's the breaking point, right? If my character is equal to a space, I'll do something. Otherwise, I will do something else. So in this case, I need to compare it, make sure, see if it's bigger than my big word. So if working word, sorry, the length of my working word is bigger than the length of my big word, then let's go ahead and set my big word equal to the working word. Is there anything else I need to do? So I'm here, and so I'm done with my loop, and I come back up here, and I go and I work again. If I hit the F, I need to make sure that I start over. So I have a new word. So in addition to this, I also want to reset my working word. So set him equal to an empty string. If it's not a space, I'm still in it. That means it's a non-space character, and it really just needs to be added to my working word. So we'll use string concatenation here. All right, so that should be something we're familiar with. Is there anything else I need to do? So what happens at the end here? So if I don't end on a space, when I get down here and I finish breaking out of this loop, there's no more letters here. My working word, in this case, it would have, if this were my line, it would have the full word of times inside it. So I kind of have to do this one more time. So I need to do this check here at the end, just to make sure that the thing that went up to the end of the line wasn't my biggest word. Let's go ahead, grab this. We'll just repeat this. So make sure it's in line with the for loop here. That means it's going to happen outside of the loop. So we're going to do one more test afterwards. And so if we did everything right, by the time we go over this loop, we go through every single line in the input, we should have our biggest word. And so we need, because the print data is using largest word, we have to just do a similar check. So if our big word being the, again, my length, the length of the big word is bigger than the length of the largest word, 4 spaces. Let's go ahead and set our largest word be equal to the big word, and largest word line will be equal to our current line. Okay, so we have, make sure we did this, get rid of, leave this here. It's just a string, so it won't do anything. But remember, we had those 3 things, so the largest word stuff should be populated. So this will go over every line of the input. Oh, that's my breaking condition. So what happens? How do I know when I'm done? So if I only type one thing in, let's just do it with one line first. And let's see what goes on. And I say, hello. So there's, if I just type, it's not gonna, you know, we're looping infinitely. So to break it, I send a Control D, and you can see rather than doing what I wanted and calculating and then printing everything out, we have this end of file error. And so this end of file error is how you know that you've reached the end of your input. So we need to check for that. How you check for errors in Python. So this would be the thing when I get to the end of file, this will cause that error. So give this a try, and try creates a block, so you have to indent. And then how to tell it you're looking for a specific type of error is I say except for exception on end of file error. And in here you will see I have the option of doing something. So when I get to the end of the input, I just want to be done. And so I don't really need to I just need to get out of this loop. I should have already set all my stuff down here. We'll go to this break, and the break will break out of the loop. And it should come down here, it should break out, and then it should continue with these print statements. So let's try that. Hello. Some more words that aren't not 5 letters long. And then I'll give it my Control D, which should give it that end of file. And then you can say, so I did something not quite right. The largest word, it's smushed together that are not. Yeah, so it's smushed together that are not. So that tells me that at some point I failed to correctly move on from my working word. So let's go ahead and pop back into the file. When I reset my working word, it's here. And so I did it only in the case that this happened. Really, every time I hit a space, every time, whether or not it was bigger or smaller, I want to reset that. So let's move this out of the if block. We want to do this every time we hit a space. And then rather than typing things in using Control D, let's go ahead and make a test file. So let's say I'll have some inputs.txt. And so this will call quick box, and then, you know, the standard over lazy dog, hippo, we would hope a quick brown fox hippopotamus. Okay, so we have an empty line to catch that. We have a big word, which we know this should definitely be our word, even if it's the only one on the line. We have some other ones. So how do we figure this guy out? So I have this file and I want to put it into the standard input. So what we've been doing is we just say, Python 3 analyzer, and then we hit enter and then it prompts for input. But on the shell, we can actually take the contents of files and we can put them into the input of programs. So I have my inputs.txt here, and so I have this left caret here. The left caret just means take the contents of this file, put it into the input, standard input here, and so it should operate on that. So that we just went through to expect hippopotamus to be the result, and it so is. So hippopotamus, the whole entire line was hippopotamus. Other words, if I add other words, excuse me, typos or not, it should be like when I print the whole line, it should have this here. So I haven't got to populating these, so they're still with the default values. But it looks like what we're doing is correct. Okay. Now you're saying, Aaron, you just lectured me on using functions, and you have a nice note telling us that it's important for the rest of the semester, but you didn't use one. So a decent rule of thumb is that, like, if you have text that is encompassing more than the height of your screen, it's kind of too much for you to process at one time. It's not a hard and fast rule, but it's decent, especially when you're getting started out. We want to break things into functions, put them into smaller pieces so that we can understand them better. And as you can see, I don't even, if I'm looking here and I've just popped in here, I don't know how far up this goes. It happens to just, my main definition is right up here. But I want to make this a function so it's readable. Because right now I have just all this code here, and if I want to figure out what it's doing, I have to look and see what it's doing. The other thing functions do is they kind of make things more human readable. So you can sort of define them, give them descriptive names, and so it'll make your code read more like a sentence or a story, however you like to think about it. So what do we want to do? So here, really all we care about to find the largest word is every single time we process a line, right? We want to look at a line, go over it, and we want to pick the biggest word out of it and see if it beats this. So I want a function that takes a line and it gives me back the biggest word that was in it. And then I can, I use the length here, I can sort of extrapolate from that how big it is. So let's go up here and define a function. So def, we'll call it extract biggest word. Take a line. All right, function, I've defined it. I've set a parameter to be line. I'm gonna expect it to be a string. We'll just go ahead and make that an assumption. And what do I do in here? Well, really, I've already done all the work. See, I have this while loop that does true. And the only big difference is I need to return what the big word is. And so let's go ahead and I will start here. So this is the comparison to see if it beats out my current one. So I'm going to copy all of this. Yeah, I'll just copy it all for now. And I will just drop it here. Now, the indentation is not the same as my main. I want to make sure the indentation is the same. So definition of my function, 4 spaces, and that's where my body starts. Now we have to return, right? We've extracted our biggest word. Let's return that. Don't need this. All right, so in this case, we can do this over and over. We can do it for every single line. In this case, now when I look at this, I don't have to deal with my loop. I don't have to think, am I inside the loop? Am I going over the file? Am I inside the loop going over the line? I just know I have a line, and the only thing I'm doing is I'm going character by character, and I'm sort of building up my word. So I return it. The other thing that I didn't talk about, in Python, these parameters, these arguments, they're called when I'm using them, they are copied. So I can manipulate this if I really want to, and it won't change in the original. So this is a local copy, so I can do whatever with this that I want. So that's called pass by value. So you make copies of things, which makes it very convenient if you need to do some manipulation. So I don't need all this. So now I have a function to do all of this. So I don't need, but I still want to set up my big word. So my big word is going to be equal to extract big word from line. And there you have it. So now my loop is very short and sweet. It's just died. Of course it did. As I All right. That's going to pop back up for me. Okay, so now my loop here is very short. I grab a line, I extract the biggest word, I see if it can be replaced, and that's all I have. That's all that I have to read when I'm looking at what happens in the main flow of the program. Okay. Last thing, I changed it pretty significantly. Let's make sure it's still doing what we want. Give it my inputs. Extract big word is not find. What did I call it? Extract the biggest word. Cool. Still grabbing hippopotamus and the hippopotamus line. So I can make my own inputs. If I wanted something more interesting to look at. If you're ever looking for just big text files that have lots of stuff, Project Gutenberg has a whole bunch of books that are public domain, and so they're free to download. So let's go ahead and do that. So let's pick the Empresses of Rome, copy the link here, and then I'm going to dump this here. So I grab my, actually, if I go in here, I want to get the plain text file. So let's grab this link. Excuse me. So it's UTF-8, not ASCII, but Python strings kind of help deal with it for you. We don't need to look at the specifics. Let's rename it from 6093 whatever to Empresses of Rome. And then if we peek inside there, of course it's not named that anymore. You can see it's got lots and lots of text. It's got chapters, page numbers, lots and lots of text. So we can run our program on this and see what we get. Let's go use our input redirect. Do it in Empress of Rome. So I don't know if you guys could tell, but it took slightly longer than it took just to process our little 3 lines of data. There was a split second there. It's just a bigger file. It's almost a megabyte, lots of stuff to parse through. So this was our longest word. Remember, we defined words to be anything not a space. So this qualifies. It's not very interesting to me. And so if I wanted to make a different kind of assumption, I can say I will consider words to be only contiguous strings of, say, alphabet characters. That's not the one I want. Backend analyzer. So let's go make. Okay, well, we're going to add another assumption. Word is a contiguous block of alphabet characters. Again, we haven't got into strings, but this Python string does have a function called isAlpha that we can use to check if it is an, A through Z, basically. So let's go ahead. It's a method that's on the string object. So let's call isAlpha here. So rather than checking if it's space, we'll have a different ending. So we want to break on anything that's not a letter. And so is this the one, if it is an alphabet, this is our breaking condition. So let's negate that. Okay, and now let's see if we pass that through, what do we get? Oh, didn't like that. String has typo. All right. So Constantinopolitan. I don't know. That is a large word. You can see the big line that it came in here. So that looks like a real word and probably a more interesting one to note. So that's what I will leave it with. And so that's what you should have in your program. So it should look for words as being, this assumption that a word is a continuous block of alphabet characters. So that should be what it does. Before I go, the last thing I kind of want to hit on is the fact that, these were passed by value, that you get a local copy to work with. So let's dive out of here. Happy fingers here. Python, let's open up the REPL, define a quick function. Oh, what did we go with? Let's say, let's just call it should do nothing. Def, let's say params are copies. 2 parameters, A and B. We'll assume for a minute that they're numbers. And I will say A is equal to A plus 1. And B is equal to B plus 1. And so I will do nothing else. So I'm just updating these local copies here. And to verify, prove to myself that that is in fact what's going on, let's set some variables. X is equal to 10. And let's say Y is equal to 20. And now I'm going to pass those in, call that function, pass X and Y in. And if I'm right, I've been telling you the correct things. So pass in X, pass in Y. So X will become A over here, Y will become B. If this will happen, X should remain 10, Y should remain 20 after this is run. So I run it, that function executes, x is still 10, y is still 20. And I think that's it. So there are other things with the functions. You'll notice I did something quirky. You don't need to know this at the moment, but it is a language feature. You see in my print data function, I have this fancy star here. Basically, this lets me take the rest of the arguments. So in reality, this could take multiple. You know, I could pass it 3 things, I could pass it 4 things, I could just pass it 1. And each one in that list there, I'm going to print out each one. I put it in this other file. That's just, you know, syntactic sugar. You don't need to know that for this class. Not right now, at least. The other thing is that you can have, let's go back in here, you can have default parameters. In this case, you can pass it, you know, in this one, what would happen if my country parameter, if you don't give me one, it's going to be Norway. So if you print these 3 out, you know, this one's going to print out country is going to be equal to Sweden. And this one, it would be equal to India. And this one, we didn't give it anything. We gave it its default of Norway. So in this invocation, it would be Norway, the default value. The scope we talked about, we kind of hit on that with them being local copies. But if you have a variable defined in the local scope, it means the variable is a local variable. So what does this mean? If I define a function, I define a variable inside a function, which I did in Analyzer here. So here I have my big word, my working word. Outside of the scope, outside of this block section here, big word and working word do not exist. They don't exist before, they don't exist after. Same if I put something out here, if I have a variable and I put it up here, you know, as I say, my var is equal to a, well, this is kind of in a scope outside of this, it's global, so this will go in here. But inside a block, things do not move out. So things can move in, but they cannot move out. And so if you want to take a look, there's global scope and global variables here. So the 300 here. So you can use it. We don't like to do this usually. This makes things messy and hard to track. So this is a bit of a no-no. You know, you only do it kind of in a break-in case of emergency kind of thing. You don't normally need to. Yeah, so the Python standard library. We have libraries, there's a bunch of functions there, you can use them. So if you haven't read the reading, I suggest you do. If it was confusing when you kind of glanced at it before, maybe if you've worked with some a little bit more, it could be a little bit better. Was there anything else I wanted to make sure I hit? Oh, the order matters. So some of you may have had problems running where you had functions that weren't exactly working. So if I drop this guy all the way down here, Python is interpreted, which means that it starts at the top of the file and it moves down. And so if any point, like, you know, in this case, I come all the way down here and I hit this, if name is equal to main, execute this. At this point, this has not been hit. So when I go up in main, all this is still fine, right? The def main is as a function has already been defined. I can go over each one of these and I can do everything. But when I get down to extract biggest word, that's going to fail because this is all the way down here. So this needs to be up top. So if I run this, even give it our versus, rather than giving us an output, we're going to get an error. And it's going to tell us it's a name error. And it says the extract biggest word is not defined. Because it was interpreted, it did not process the entire file. It only got down, you know, it goes line by line. It follows the flow until it hits it. So any functions that you want to use, you got to put up here. So And if you have functions that call other functions, you have to go ahead and move them up as well. So um, if you're getting a name error for functions, your order may be off, or you might have a typo. So the lab, so I've done this, so you can either sort of, if you copied along and you're getting the same output, you'll have that. You need to do these last two things. So as part of the loop, you have to go over the entire line and you have to find print out the line that has the most U's, print out the line that has the most spaces. You should also keep track of how many. So the ones that have the most U's, go ahead and keep that value here. You will need both. You need to be 100% correct. So we're reviewing this topic. For programs should be 100% correct. So don't add any output. If you use any to debug, that's fine. Just make sure you remove it before you hand it in. So I've already done this one. So you guys need to, fill in what I've done or do it yourself. And then you also need to hit these. You need to populate these. Remember, we are in a loop here. So if I were you, I would take this, and my line is still a valid line here. So I would, find most U's in a line using a function. Find most spaces in a line using a function. You are required to use functions. If you don't, that will also count. This assignment, this lab is, you have to get used to writing your own functions. So you have to use one for both of these. It doesn't have to be the same function. It maybe can be. So that is your assignment. I remember I have office hours Tuesday morning. It's from, what is it, 7:30 to 9, 8:30 to 10. I have those Tuesdays and Thursdays, and then if you just message me on Teams, I should be able to respond. So good luck, guys.